Okay, so now we're going to talk about the moment of inertia of different shapes. So we previously talked about the moment of inertia of point masses. And again, a point mass is just some little mass in space that is some distance from a pivot point. And so again, for a point mass, that was like m1r1 squared plus m2r2 squared plus so on, so on. So let's say we had some mass here, some distance away from a pivot point, and x is the pivot point or rotation point. So that is just going to be mr squared. Great. So now let's say we have shapes where like the object of a whole has some mass. So let's say we have a rod. So for this rod right here, and let's say this rod is rotated about its endpoint, okay? So this is the pivot point. So and let's say the mass of this rod is m, and let's say the length of it is l. So for this rod, should the moment of inertia be more or less than mr squared? Go ahead and think about that and then check back in. Okay, so think about it. For this rod right here, not all the mass is some distance away from the pivot. Some is closer. So if the mass is like closer to the pivot point, it's a lot easier to rotate things when the mass is closer to the pivot point. So the moment of inertia of this should be smaller than just mr squared. So for a rod, in this case, it is going to be 1/3 ml squared if it's rotated about the end. If it's rotated about the center, it's going to be different. So I have a good old table that I got from my favorite physics textbook, Young and Friedman, and this is the moment of inertia of different shapes. So I encourage you to just check it out. Keep in mind for all these things like rods, m is the mass of the rod, l is always the length of the rod, so the entire length. Well, if we look at these spheres and rings and cylinders, r is going to be the radius of the rod. Great. So I encourage you to write down a couple of those in your notebook. But let's go ahead and do a couple practice problems. So using that table, what I want you to do is I want you to calculate the moment of inertia of each object. So go ahead and just do this yourself, and then go ahead and check back in. So again, number 1, 2, and 3. Cool. So now I'll go ahead and post the answer for each one. So we have a solid sphere. So I look at my table that we had just posted, and a solid sphere is 2/5 mr squared. So I can just plug everything in. It's 2/5. The mass is 5, and the radius is 3 squared. Great. So I got for this 18 kilogram meter squared. Cool. Now let's do number 2. So thin rod rotated about its center. So a rod rotated about its center is 1/12 ml squared. Cool. So that's 1/12. Mass is 6. Length is 5 squared. I got 12.5 kilogram meter squared. Great. So I should box that answer. Cool. So now let's look at number 3. A thin rod, blah, 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 and it's rotated about its end. So that is going to be a rod rotated about its end. I'll look at my table, and that is 1/3 ml squared. So we have 1/3, the mass is 6, and the length is 5 squared. Great. So I got 50 kilogram meter squared. Great. So I'd like to just talk about the answer to 2 and 3. So both of these are a rod of the same mass and same length. So same rod, just rotated about different points. So in one of these, it's rotated about the center, and one of these, it's rotated about the end. So what I encourage you to do is go ahead and take your pencil or pen or writing utensil, whatever it is, rotate it about the center, just between your fingers, and see how that feels. Okay? Now rotate it about the end, and see how that feels. Okay. Which one was harder to rotate, about the center or the end? I had a lot harder time rotating it about the end. Cool. The good thing is that all deals with inertia. The more rotational inertia something has, the more resistant it is to changes in motion. So when I try to rotate it about the end, it has a higher moment inertia, 50, compared to 12.5 if it's rotated about the center. So more inertia means it's harder to get rotating or harder to like slow down and stop its rotation.